Alright, so today is going to be about hyperbolas, and this is the last conic section that we are going to talk about, and then in the next section after this we'll just be using transformations to move the conic sections, or what they call shifting the conic sections. So a hyperbola is the set of all points in the plane, the difference of whose distances from two fixed points f1 and f2 is a constant, and these two fixed points are called the foci of the hyperbola. So here, this is called one of the foci, so this is a focus over here, and this is a focus over here, and then you can see that if P is a point on the hyperbola, then the distance between the P and F1 minus the distance between P and F2 will be equal to 2A. So what is A actually equal to? Well, alright, if you look at the next the next page here, you can see that if you have a hyperbola with the foci on the x-axis, like you have here, then you can see here that, well, here I'll show you again, because this is the strange part to me. All right, so you can see that this actually is going to be the point of where is it? Negative a 0, and this one is negative a 0, and that is a vertex, and that is a vertex. And then you can see that you have going through the origin, and I'll try to draw this so that you can see it here. All right, so if you have a line going through the origin, and this is going to be one of the asymptotes. All right, so this will be one of the asymptotes, and then, oops, there we go. And this is going to be one of the other asymptotes, like this. All right, so here's one of the other asymptotes, and then you can see that they are telling you that there's a point that is, say, B over here, so B, and so this will be 0, B, and this will be 0, negative B. All right, so the distance from P to F1 minus the distance from P to F2 will be 2A. So what they're actually saying is that this right here, this distance right here is 2A, but the the difference between this, all right, the difference between this and I'll show you here, right, this one right here, and this one will be equal to that yellow part. All right, and actually, I knew there was some sort of problem here, because this yellow highlighting went too far, but there you go. So I think that you get the point there, but that's all I really want to make sure that you understood, is that when they drew it on this diagram here, it's sort of not as clear as just saying, like here. This is sort of like the XY here that they had that with point P, so this and this and this. All right. So so just be aware that the A and the B do have a meaning to them, and where they're located compared to over here. If you have something similar in here, say like a point P, X, Y, and you have a distance from the F1 to the P, and then from the F2 to the P, and so the one distance minus the other will still always be equal to the 2a, the length of the major axis from between the on the major axis between the two vertices. All right, so now the major thing also that you need to remember is that when we're talking about the equation of a hyperbola here, there is a minus between them here. All right, so when we were talking about the ellipses, there was always a a plus between the two terms. All right, now here, the thing that I think confuses people the most is that the A is always under the A is always under first the first term, all right? But the only reason why that is because whatever variable the A is under is going to be the larger one here. All right, and you wouldn't ever want to subtract these in a different order because then you would get a negative number when it's supposed to equal a positive one. All right, so just try to remember that also. So here you can see again that the A's represent the vertices, so the A's are always on the the transverse axis is what it's called here. All right, so that's really the same equivalent as a major axis. All right, so the horizontal length is 2a, and then these asymptotes are just b over a. But I hope that you can see that the b is the rise and the a is the run to make up the slope of that line. So you go from the origin and then up b and over that a, and that will give you the line right through the origin. And then the same thing for the other direction. You go down b and then over a, and you're on this line going the other direction. All right. So the other thing is that you do have to deal with the foci here, and so this is the important equation to keep in mind to find the c for where the foci will be, and that is c squared is a squared plus b squared. All right. Now, I hope that you can see sort of in the middle here a sort of rectangle here that is drawn here, and here you can see over here. It's not dashed like the asymptotes, but it's not part of the graph either. All right, so that rectangle is what some people call, all right, that I'll write over here, but they don't label it on the different items you should probably usually find, but it is for some people called the fundamental rectangle. All right, so the couple of things that I want to make clear to you is that if you notice here, right, this is actually the same sort of setup that you would have for an ellipse, but instead of drawing the ellipse in here, right, instead of drawing an ellipse like this, right, this is how we would normally have drawn the ellipses between the A's and the B's, right? Instead of drawing it as an ellipse, you draw a rectangle, and then the the A's are the vertices. So a point on the graph actually has to be touching the rectangles, and then you draw the asymptotes, and then have the hyperbola go from the vertex out toward the asymptotes. All right, that's all. So try to make sure that you're very careful and deliberate as to where the vertices are so that you don't incorrectly draw the hyperbola. So as you can see here, another way to name this fundamental rectangle is just as the central box. All right, so there's lots of ways that people name this rectangle here, but it's not one of the parts of the actual hyperbola, and so it wasn't up here with the different characteristics that you see. All right, so as I mentioned, draw the box, then the asymptotes and the vertices. Make sure that they are on the box, and then draw the hyperbola through the vertex, but panning out toward the asymptotes. All right, so now let's try one of these. So here we see that this is the larger number here under the y squared, so that means that the transverse axis will be a a um, vertical transverse axis. So the transverse axis is vertical because the larger number was under the, well, actually, it doesn't really matter if it's a larger number, but it does matter that the y squared was the first variable here. So we have y squared over a squared minus x squared over b squared is equal to 1. So we know that the a squared is equal to the 81 and the b squared is equal to the 16. So the square root of 81 is 9. So a is 9 and square root of 16 is 4. So b is 4. All right, so the main reason that you would want to find the transverse axis first is just so that you know which one is going to be the A and which one is right, which one is going to be the A, and so then you know whether this is going to be vertical or horizontal. All right, so now we need the vertices, and then we need the foci, and we need the length of the transverse axis, and then we need the asymptotes. And then finally, we'll sketch the graph when we are done. All right, so for a hyperbola with a vertical transverse axis, the vertices are at 0 and plus or minus a. So a was 81, so this, well, a squared was 81, so a will be 9, so that's 0 and plus or minus 9. And the foci are at 0 plus or minus c, but c squared was a squared plus b squared. So since a squared was 81, and b squared is going to be 16, then c squared is 81 plus 16, so that is 97, and I take the square root, so c is the square root of 97, so that will be 0 and plus or minus the square root of 97. But that square root of 97, if I go ahead and I show you that real quickly, so square root of 97, that's about 9.8. So that will be 0 plus or minus 9.8. All right, and then the length of the axis here is just going to be 2a, so that will be 2 times the a, which is 9, so 18, and the asymptotes are at y equals plus or minus a over bx, so that's plus or minus, and 9 was a and 4 was b, so plus or minus 9 over 4 x. All right. So now let's go ahead and we will sketch this here. So here is the axes, here is the axes right here. So what I do, this is fairly straightforward, the same sort of setup as with the ellipse. I need to draw the A's and the B's on the correct axis, so the A's go on the transverse axis, which was vertical, so 1, 2, 3, 4, 5, 6, 7, 8, 9, and there is a vertex. 1, 2, 3, 4, 5, 6, 7, 8, 9. Here is a vertex. I would draw the point in so that you don't forget to make sure that the points here are actually on the hyperbola. And then the b's were 4, so I will go 1, 2, 3, 4 to the right on the x-axis, and 1, 2, 3, 4 to the left on the x-axis, so -4 and 4. And then, all right, now then I can draw a central box. So here it is. So here is my central box, our fundamental rectangle, and it's really the same idea as if you were drawing the ellipse. It's just you're drawing a rectangle now. And then, because you know that the transverse axis is vertical and the hyperbola has to go through the vertex, you know that it's opening up and down and not left and right. All right, so it doesn't have to go through these points. These points are just to help you set up how wide the hyperbola is opening. So you really don't necessarily need to know the equation of the asymptotes, because the asymptotes are going to go through the diagonals of the box. All right, so always remember that you don't really ever need to know the equations of the asymptotes unless you're being asked. All right, otherwise you can just draw the asymptotes quickly through the diagonals of the central box. And then, as I mentioned here, the hyperbola goes through the vertex and then pans out toward the asymptotes, but no wider than the asymptote, so it cannot cross the asymptote. So here it is. So that is a sketch of this hyperbola. All right, so I hope that you enjoyed that here. So that shouldn't again have been too difficult because it's very similar to the overall procedure of how we were sketching an ellipse. So let's go ahead and try another one here. So here we have 9x squared minus y squared equals 81. So remember that these need to be equal to 1, so we will do something similar to what we did for the ellipse. We'll divide by 9, 9, 9. Or actually, 81, 9 times 9. I didn't even realize I just did 9 and not 9 times 9. All right, so then 81 over 81 is 1, and so 9x squared over 81 is just x squared over 9, so that's x squared over 9 minus y squared over 81 is equal to 1. And then you see that this, because the x squared is right over here, that we need to have a transverse axis that is horizontal this time instead of vertical. All right, so that's really the main difference here. So a squared is 9, b squared is 81. So that makes a 3 and b equal to 9 when we take the square root. So again, this is of the form, what is it? X squared over a squared minus y squared over b squared is equal to 1. All right, so now what did they want next? They wanted the vertices, and they want the foci, and the length of the transverse axis, and the asymptotes, and a sketch of the graph. All right, so here we go. We'll find all of these. So the vertices are at the plus or minus a0, foci at plus or minus c0. The length of the axis is still 2a. The asymptotes are at oh, y is equal to the plus or minus b over a x, and then here we can draw the sketch of this in a second here. So all right, so the A was 3, so the vertices are at plus or minus 3, 0. And just like before, the C squared was A squared plus B squared. So here we have, since A squared was actually 9 and B squared was 81, then we have C squared is actually equal to, what is that, 90? So C is the square root of 90. And let me give you an estimate of this so that you can see sort of where that might be on the graph, about 9.5. So we know that the foci are at plus or minus the square root of 90, 0, or about plus or minus 9.50. And the length of the axis is 2a, so 2 times 9, 18. And the asymptotes are at y equal plus or minus b over ax, so plus or minus, that will be 9 over 3x, or just plus or minus 3x. So now let's draw a sketch here. So where did my ruler go? Oh, there we go. So let's draw a sketch here. So here is what this will look like today here. So the vertices are at plus or minus 3, 0. So 1, 2, 3, negative 3, 1, 2, 3, positive 3. Remember to draw the points in so that you make sure that they are actually part of the hyperbola. And then the B was actually 9 here, so I will go up and down 9 on the vertical axis, the y-axis. All right, so this will be 1, 2, 3, 4, 5, 6, 7, 8, 9, and 1, 2, 3, 4, 5, 6, 7, 8, 9. And remember that these are just going to be guidelines for drawing the asymptotes now. So the asymptotes will actually go through the corners of this fundamental rectangle or central box that I'm drawing in. All right, so you can draw that in if you, again, if you would like to, but it's not actually part of the hyperbola. It just really helps people draw this a little bit more easily. And the asymptotes go through the diagonals of that box. So here we go. And here is the first one, and as close as I'm going to get, right? Oh boy, this is rough without any graph paper, right? Okay, so here's one of them, and here is the other one. And then I can draw the, oh boy, then I can draw the hyperbola after that. So make sure again that the points on the transverse axis are actually on the hyperbola. So I'd start at that point and then draw the hyperbola out toward the asymptote. So start at the vertex and draw the hyperbola out toward the asymptotes. All right, so that is the sketch of, what was that, 9x squared minus y squared equals 81. All right, again, if you have any questions, please feel free to ask. But now let's go ahead and move away from the uh, the the graphing here and to finding the equations for a moment. So find the equation for the hyperbola described, sketch the graph and its asymptotes. Okay, so let's actually start by drawing this sketch, because sometimes that will help us figure out what the equation should be. All right, so let's draw the sketch, and here we go. So here is the y-axis, here is the x-axis, and they tell us that foci are at 0 plus or minus 8. So that's 0 plus or minus c, and the vertex is at 0 plus or minus 2, so that's 0 plus or minus a. So I know that because the vertexes in the foci are on the x-axis, right? So here is 1, 2, and um, sorry, y-axis. I have no idea where I was going. I was thinking about I was thinking about some. I was off in space somewhere. All right, 0 and plus or minus 2. So here is one of the vertices, and here is the other vertex. So we know that the transverse axis is going to be the y axis now. So this means that because this has a transverse axis that is going to be vertical, that the form of the equation is y squared over a squared, and that's minus x squared over b squared is equal to 1. And so all we really need to do is figure out what b is now. But since c squared is a squared plus b squared, and c was 8, and a was 2, we have 8 squared is equal to 2 squared plus b squared. So 64 is equal to 4 plus b squared. You can subtract the 4 to get 60, so 60 is equal to b squared. Or b is equal to the square root of 60, and the square root of 60, I'll show you right here. So square root of 60 is about 7.7, so that's about 7.7. All right, so if I go 7.7 each direction on the x-axis, 1, 2, 3, 4, 5, 6, 7.7, and 1, 2, 3, 4, 5, 6, 7.7. All right, so this is the negative square root of 60, and here is square root of 60. Then I can draw my fundamental rectangle or central box pretty easily. All right, so let's just draw in my box here, and then I can go ahead and draw in the asymptotes. And then if I draw in the asymptotes, all right, so here is one of them. Oh, there we go. And here is the other one. And I know that the equation of the asymptotes is actually just going to be y is equal to plus or minus a over bx. So this is actually, where is it? Y is equal to plus or minus a was 2, so 2, and b square root of 60, so 2 over the square root of 60x. So that is the asymptote. And then we need the equation. So if I just substitute the a squared and the b squared in, then I have the equation. So b squared was 60, and if a is 2, then a squared is 4. So we know that the equation is y squared over 4 minus x squared over 60 is equal to 1. And there's the equation. And now I just need to graph the hyperbola. So I start at the vertex right here, and right here on the transverse axis, and then I pan out toward the asymptote. So there is one part of the hyperbola, and here is the other part of the hyperbola. So hopefully this isn't too difficult, but it is a matter of just making sure that you know what A and B are, because if you don't know what A and B are, then you can't actually graph the hyperbola or find its equation. All right, let's try another one here. So here we see that the foci are at plus or minus C0, and so that means that the the transverse axis is going to be horizontal, because the foci are always on the transverse axis. All right, so the C is equal to 6, and the transverse axis is going to be horizontal. And so when I have a horizontal transverse axis, I know that the asymptotes are y is equal to plus or minus b over a x. All right, so now all I really know so far, then, just so that you're clear on this, is I don't know that a is equal to 1 and b is equal to 1, but I do know that since this is the same as plus or minus 1x, that b over a is equal to 1, and that b is equal to a. Right? But I don't know that they're both necessarily 1. So the other thing I also know, though, is that the c squared is a squared plus b squared, and I know c is equal to 6, so 6 squared is a squared plus b squared. And so then I also know b is equal to a, so I'm going to substitute that in here. So I have 6 squared is a squared plus a squared, and so 6 squared is 36, so 36 is equal to, now I have 2a squared, then I divide by 2 to get 18, so 18 is a squared, and then I can take the square root to get a is equal to the square root of 18. And so that means that the b is also the square root of 18, since a was equal to b. All right, so then the square root of 18, let me show you what that is. So the square root of 18 is about 4.2. So I want to point out that the number 1 and 2 biggest mistakes that I probably see people make are, one, as I've been mentioning, that they draw the sketch too quickly and the graph doesn't go through the vertex. But the other one is a wrong assumption that a and b would be equal in this case, because we actually don't know what a and b are until we go ahead and find them. All right, so square root of 18 over square root of 18 is also equal to 1. So there's lots of possibilities that it could have been, but this is the only one that would work in this particular case if c was equal to 6. So now I I know that I can go ahead and write down the equation here. So if a squared is equal to the, here, let me draw this in here. So if a squared is equal to 18, that means that b squared is also equal to 18. And I can write down the equation then. So because this is a hyperbola with a transverse axis that is horizontal, the equation is of the form x squared over a squared minus y squared over b squared is equal to 1. And these are both equal to 18 here. So what do you have here? You have x squared over 18 minus y squared over 18 is equal to 1. So there is the equation of this hyperbola. And now I am going to go ahead and draw the sketch now. So here is the sketch. By the way, I hope that this doesn't seem too much all over the place. It's just that you're not going to follow the same path to find the equation or the graph in every case. It depends on what the information is that is given. All right, so let's go ahead and we will draw the graph here. All right, sketch the graph. So the vertices are along the horizontal axis, or the x-axis. So we saw that they were at the square root of 8 18, which is about 4.2. So we have 1, 2, 3, 4.2, and 1, 2, 3, 4.2, and then 4.2 up on the y-axis, and 1, 2, 3, 4.2 down on the y-axis. So you can label all these if you would like. This is, of course, the square root of 18, negative square root of 18, square root of 18, negative square root of 18, all right? And then draw in the central box or the fundamental rectangle here. So after you do that, you should be fairly all set to draw the hyperbola, hopefully. So I hope that this is all seeming like it's not too bad. It's just a matter of knowing where the vertices are and going from there. So what do we have here? This is, like I said, this is a lot going on, but it all depends on what information is given in the problem. So here we go. So here is the, oof, right? What a time to be alive, right? So here we go. Here are the asymptotes going through the diagonals of the central box here. And then the hyperbola will start at the vertex and then pan out toward the asymptotes like this. Start at the vertex, pan out toward the asymptotes. And that's it. All right, so now let's try another one. And in these last three here, the graph is going to be given, and we will just try to find the equation of the hyperbola. So again, if you have any questions, please feel free to ask. But here we go with this one right here. So here you have a foci at 0 and plus or minus 13. So 0, C, 0, negative C. So C is 13. But then you see that here is the vertex, and the vertex is at, it looks to be at 1 at the, oh, there is 0, 12, and 1 at the point of, here's a vertex also, and it's at the point 0 and negative 12, so that will be 0a. So in negative a, so that means a is equal to 12. So you can figure out what b is, because c squared is equal to a squared plus b squared. So if c was 13, we have 13 squared equals 12 squared plus b squared. 13 squared is 169. 12 squared is 144. I can subtract here. So 169 minus 144, that is 24. So 24 is equal to b squared. And then let's figure out what b is. B is the square root of 24. So that is about, let's see, what is that? That will be about 4.9. But again, that really didn't matter here, because what we notice here is that the transverse axis is going to be, well, it's vertical here, so a vertical transverse axis. So that's important, because it means that the hyperbola is of the form, all right, so that will be y squared over a squared plus x squared over b squared is equal to 1. And a squared, well, if a is 12, a squared is 144. And we already know b squared is equal to 24. So we have y squared over 144 plus x squared over 24 is equal to 1. And that is the equation of this hyperbola right here. All right, so hopefully, again, that isn't too difficult. And then let's try another one here. So here, what do you see here? Well, you see the two vertices. So we know that the a hyperbola has a horizontal transverse axis, and so that means that the hyperbola is of the form x squared over a squared plus y squared over b squared is equal to 1. And so here's the vertex, and it happens to be, well, you can tell that they told you that this was 2 square root of 3, so this is negative 2 square root of 3. So it's at negative 2 square root of 3, 0, or negative a 0. And here is a vertex at the point of, well, 2 square root of 3, 0, or a 0. So then I know that a is equal to 2 square root of 3, and so a squared is 2 square root of 3 squared, so that is 2 squared, which is 4 times 3, so it's 12. All right, so a squared is equal to 12. And so I can substitute this in here. But then they don't tell me anything else except for an x and a y over here. So I'm going to use this x and y, a point on the graph, to figure out what the b is. So the x that they give me is 4 and the y is 4. So we have 4 squared and 4 squared, but they don't tell me what b is. All right, so this one is a little bit trickier, but we can figure out what b is. So 4 squared is 16. So we have 16 over 12 plus 16 over b squared is equal to 1. And then I will actually just go ahead and subtract the, well, it really, like I always say, it doesn't really matter how you want to deal with this. If you want to multiply through by 12 to clear the fraction here, you're more than welcome to. All right, so then what would that give you here? That would be 12 times 16, 192, right? So 16 plus 192 over b squared equals 12. Subtract that, so that would give you the, oh boy, well, okay, so, well, if you subtract here, so 16 times 12, 192. So where am I going with this? All right, so yeah, so then you would subtract the 16 here. So 192 is equal to, where, something is, something, honestly, now that I'm seeing this, something seems very something seems strange about this, because this doesn't seem like it this doesn't seem this doesn't seem like it can be right, because this should end up being, as you can see here, this will end up being some uh negative number, right? So if I go ahead and I figure out the oh, you know what? That's, oh, sorry, because I wrote down I wrote all of these with a plus, and they should be minus. There we go. It's because I told you I was out in the loopy world somewhere, right? I was out in the loopy world somewhere. All right, so negative 192 over b squared is negative 4. So negative 192 will be equal to negative 4b squared, and then divide by negative 4 on each side. So then if I do that, then b squared is equal to 48. So then I know what a squared is, it's 12. I know what b squared is, it's 48. If I want to find b, I can, right? So b is the square root of 48, and then that will be, what will that be? That will be 6.9. All right, so then, uh, well, then you just have to write down the equation by substituting the a squared and the b squared in here. So just go ahead and do that right now. So what will that be? That will be x squared over a squared, which is 12, minus the y squared over b squared, which is 48, and that will be equal to 1. So that is the equation of this hyperbola. So again, I don't think that this is very difficult compared to what we were doing before. It's just you have to be careful to every little piece of information that they give you, including like what the equations are, because I accidentally was out in the middle of nowhere and wrote plus instead of minus, and then I only realized it because I realized that it would have been a disaster to take the square root of a negative number here. All right, let's look at the last one in this section here. So we have the graph here, and you see that the vertices are right here at negative 5, 0, and 5, 0. So these are vertices. So these are vertices, and these are vertices. And then you can see that these are of the form plus or minus a 0, so they look to be at, well, plus or minus 3, 0. And then for a hyperbola with a horizontal transverse axis, the form is of the form x squared over a squared minus y squared over b squared is equal to 1. And then also the other thing that you know is that the asymptotes, these are for hyperbolas with a horizontal transverse axis, are of the form y is equal to plus or minus the b over a x. So this is plus or minus 1 over 2x here, all right, 1 over 2x. So now, what do I know then? Well, I know then that b over a has to equal 1 over 2, but I know a was equal to 3, so I have b over 3 is equal to 1 over 2. So then I multiply by 3 to get b is equal to 3 over 2, or 1.5. And so if a is equal to 3 and I square that and get 9, and b is equal to 1.5 and I square that to get 9 over 4, or 2.25, then I can just go ahead and substitute the b squared, or substitute those into the equation of the hyperbola. So what do I have in this case? It will be the x squared over 9 minus the y squared over 9 over 4 will be equal to 1. And then here I can just multiply by the reciprocal to get x squared over 9 minus, all right, and so that will be 4y squared over 9 is equal to 1. And that's only, again, because I don't necessarily want to mix the fractions with another fraction. And then I can just multiply through by 9 to clear the fraction. So I have x squared and minus the 36y squared is equal to 9. And this is another way to write the equation of this hyperbola. So either of those is okay. All right, so unfortunately that is the end of this section right here on hyperbolas, and these ones were just ones that were centered at the origin, but we'll of course go over more complicated ones later.